Hey, well, hello, my geometry friends. Here we are with homework 1.5. We're on formulas, geometric formulas. So, chapter one's a little bit of a grab bag of topics. We were just doing lines and segments and then angles, and now we're just kind of doing basically it's a review of basic formulas. So, let's jump right into the notes section for homework 1.5 and the definitions. Okay, so our first definition is actually a comparison of definitions, area or perimeter versus area. And I just wanted to reinforce what is the difference between perimeter and area. Basically, perimeter is the distance around. So perimeter is the distance around an object. So if we were to, we'll draw a little picture here. Or actually, well, we'll do it this way. If I draw a basic shape, nice little rectangle or square, perimeter goes around the object, and so it is a linear distance. That's the other thing we want to note, a linear distance. In other words, it's a one-dimensional distance. So when you do units, you would do it just in terms of just plain old units. I'll compare that to area in a second. But it's just like even though you're not traveling in a straight line, you're not covering multiple dimensions. It's just length, basically. So it's the length all the way around an object. When it comes to area, that is the area covered by an object. So in other words, the area of this shape would be everything inside here. So that's the area. Or sometimes you can think of it as the area contained within an object, but that sounds a little bit more like volume. So the area covered by an object, and that is squared, or we'll just say two-dimensional. Two-dimensional, or what we might call your units squared. And so what I mean by that, units versus units squared, is say this was this rectangle here was measured in inches. My area would be expressed as far as inches squared, because a unit of area actually has two dimensions. And when we give that distance, we're actually saying, well, it's an inch. Whoops. Let me clean that up. Oops. An inch by an inch in two dimensions. Whereas in perimeter is just one dimension, and it would just be an inch. So again, whenever you're doing perimeter, your unit should always just be plain inches, feet, centimeters, whatever. If you're doing area, it should be inches squared, feet squared, centimeters squared. And again, distance around versus distance covered. Okay, diameter versus radius. These both are terms that apply to a circle. And there's two important ways, to express it. The diameter of a circle is its width that passes through the center. So diameter, actually, let me go ahead and move this because I want to write here. Its width, oops, sloppy, sorry. Its width through the center. I'll go and abbreviate this, through the center. So if I have a circle here, and we have our center of the circle, beautiful circle, the width of the circle through the center, so not just any width, not like this, because that doesn't go through the center. So that's top one is not the diameter. That one right there is the diameter because it's going through the center of the circle. Whereas then the radius is the edge of a circle to its center. Okay, so we'll just say width to the center. And so that would be, so from here to the center. So that would be a radius. It only goes halfway across the circle. And so that's the other thing you could put, is you could put here half the diameter. Again, sorry for not being a little neater or having more space. So in other words, if you know the diameter, you know the radius is half of that. Or if you know the radius, then you know that the diameter is twice that. That might be something worthwhile noting here. let's just switch colors, but that 2r, 2 times the radius, equals the diameter, okay? Because it's halfway. Basic terms when we get to our definitions or our formulas. We want to make sure we know the difference between, and you'll get stuck on a problem sometimes. Make sure you check, is it giving you the diameter of the circle all the way across, or is it giving you the radius of the circle, just half of it? Okay, the area of a rectangle. So we're just still in our basics. Hopefully this is some nice review for you. But if we have a rectangle, something like that, 2 sets of parallel sides, one side longer than the other. One doesn't have to be, but there's our rectangle. Two-dimensional figure, we have our length and our width. Okay, so the area of a rectangle is simply the length times the width. If I know that I'm so many units tall and so many units long, if I multiply those, it tells me how many square units that shape is covering. Okay, so pretty simple, straightforward. Then we get to triangle, area of a triangle. Alrighty, let's draw ourselves a nice triangle here. Beautiful. Area of a triangle is basically every triangle is half of a rectangle, maybe half of a parallelogram, but it's half of it. In fact, maybe I can show that to you. I'll do it that way. I'll just draw it more like this, where we have our, there's our, I'll leave our rectangle right there, is that a triangle is this. So a triangle is often half of a rectangle. Even if I were to not make this a right triangle, it would be half of a parallelogram. So the same formula applies, where again, if I have, again, where you might have length and width, you can see that it's going to be the same, except only half of it. So that's why the area here is area equals 1/2. And now because we do need to have the specific height of a triangle, you're going to, and they're not always at perpendicular lines to each other. We actually we don't say length and width, we say base times height. And so here, rather than length, we would call this the base, and we would call this the height. So it's the base times height, but then cut in half. And the reason we do that is because you could have another triangle. Say I drew it, I'm just going to scribble it here real quick, and we'll erase it. Here, where again, here's my base, but this distance here is not the height. This distance here is not the height. It would actually have to be perpendicular from the base, and that would be considered the height. So that's why we don't use length and width for triangles, because the edges are not necessarily the dimensions we want. One of them will always be, and we call that the base, but then we need a perpendicular height from that base to be our height. So area of a triangle, base times height. Circumference, that implies a circumference of a circle, because all circumference only applies to circle. In fact, so if we have a circle, the circumference is just actually another name for perimeter. It is the perimeter of a circle. Okay, so when we say circumference, we are trying to figure out the distance around a circle. Okay, and the formula for that is C for circumference equals pi times the diameter. So in other words, you take your diameter, which is your distance across, and you multiply that by pi, and that gives you your circumference. Now, what is pi? Well, without getting into it too complicated, pi, first of all, we'll do it basic form. Pi is basically, it's that symbol, pi right here. It's equal to 3.14. Now, that's approximate, so actually I should write this right here, more like this. It's approximately 3.14. As a fraction, it's approximately 22/7. And what it is precisely, if I can squeeze it in somewhere, maybe I'll erase this right here. What pi is exactly, it is circumference divided by the diameter. Kind of a cool trick if you want to try it for all you investigatory geometry lovers out there, is take anything perfect that you know to be round in your house. If you measure the circumference of that circle, and then you measure the distance across the middle through the center, divide those two measurements, no matter what you decided to measure, whether it's a bike tire or maybe a coffee can or maybe the base of a circular cup. If you take the circumference, measure it, and then divide it by the distance across through the center, you'll get something very close, depending on how accurate your measurements are, to 3.14. That's actually one of the definitions of a circle. Is for something, if something's a true circle, its circumference divided by its diameter will equal that 3.14. And you can actually see that if you look at our formula. Look at this. When we say C equals pi times D, if I did a little algebraic reworking and I divided both sides by D, and I canceled that out, I could see, oh, look, pi is equal to C over D. And so again, it's just kind of neat. It's not some random number plucked out of the ether. It was something that the Greeks, ancient Greeks, first recognized in studying circles, that they all have that ratio in common. And if that division doesn't work out, circumference divided by diameter being approximately 3.14. In fact, it's an irrational number. You can memorize it to several places. It just keeps going infinitely. That is constant for everything that is truly circular. It's a test actually to see if something is truly round or circle. But anyway, that might be going too far for some of you. Pi is just approximately 3.14, and you multiply that times the diameter and you get the circumference. Again, the other thing you could note is you can also write this equation in terms of the radius. C is equal to 2 pi r. And that just means that because the radius is half of the diameter. So if you have the radius, just double the radius and then multiply that times pi, and you'll have your circumference. Okay, and then I didn't leave myself much room here, but the area of a circle. And the big key thing here is to differentiate these. I see students all the time mixing up, just like supplementary, complementary. They mix up circumference formulas and the area formula of a circle. You really want to get those straight in your head, or you'll be tortured making very avoidable mistakes. And so the area of a circle is the famous formula built off the radius. Area equals the pi, so 3.14 approximately, times radius squared. So you square the radius times itself and multiply it by pi, and you have the area. So you'll want to differentiate these. Pi times diameter, or 2 pi r, versus area is pi times r squared. The quick way that I remind myself of that is, you're making a mistake, is if you can remember that circumference is linear. There's no square units. It's just inches, feet, whatever. Whereas area is always the distance squared. Well, of your two formulas, only one of these has that exponent, r squared. So have that be a trigger, that r squared goes with the area, whereas the plane, say 2 pi r or even pi d, the other way to do it is the circumference has the diameter involved, there is no square. It's just a linear formula. Okay, so let's look at, I think we got 3 questions to practice some of these things here. So question number 1 tells us find the perimeter and the area of that triangle. I've gone ahead and drawn that triangle. And so we'll go ahead and start with the perimeter. And so we've got P. So remember, perimeter is simply the distance around. So since I know the lengths of the triangle all the way around, I can just add those up. So my perimeter is equal to 8 plus 40 plus 10. So my perimeter is simply 58. Now again, we've talked a little bit about naked numbers, so we don't want any naked numbers. So we can see what our units are: feet, because if you're building something, you're going to want to know, is it meters, yards, feet, inches, centimeters, miles, light years? It's going to make a big difference. So 58 in this case, 58 feet. And it is just perimeter, so it's not feet squared, it's just linear feet. Alrighty, and then we've got the area of the circle, which is pi r squared. So before we do that, notice we set our formula up. Oh, actually, we never did a formula of perimeter. Okay, good. Yeah, you're just tracking, you're adding up the distance around a shape. The area of a triangle, we have 1/2 base times height. Oops. 1/2 base times height. Okay, so that means I got 1/2 times the base. Oh, that's 10. And then notice the height is, again, the perpendicular distance from the base. So that's not the 8 or the 40, that's the 6. I couldn't use the 8 or the 40, not till I learned some tricks on how to use those to find the height. So we have 1/2 times 10 times 6. What I highly recommend is just remember that fraction. If you're like, oh no, I hate multiplying by fractions, just remember a fraction cuts up the number by that amount. So that half, you're just going to cut your total area in half. So you could think of this as either cutting the 10 in half and just doing it 5 times 6, which is 30. Or you could think of it as first 10 times 6, which is 60, and then cut that in half, which is still 30. Or heck, you could go 1/2 of 6 is 3, 3 times 10. You're going to get the same number. But just remember that half cuts one other number in half. So I'm going to go ahead and think of this as just 5 times 6, applying that 1/2 to the 10. And so then my final area is going to be, put it over here, 30. And in this case, it is feet squared because it's area covered in 2 dimensions when I'm talking about area. Okay, let's do the same thing. Now we're going to do it for a circle. Circle, it says, find them both for a circle with a diameter of 8. It also says to leave in terms of pi. So I'll explain that and demonstrate it. So circumference is just a fancy word for circles and the distance around them, perimeter. So circumference is pi times d. Now watch out, this problem is going to be really hard. It's going to hurt you. No, not really. Pi times the diameter, the distance all the way across that circle is the 8 feet. So I can just simply replace that and go 8 times pi equals my circumference. Now, when it says leave it in terms of pi, again, because 3.14 isn't actually the right amount, it's rounded, so it's slightly inaccurate. A lot of times, if we leave it in terms of pi, it's a more perfect answer. It also doesn't require us to maybe pull out a calculator and do 8 times a decimal of 3.14. So if it says leave it in terms of pi, once you have everything simplified next to pi, that's your answer. And we can just simply put our units. This is also feet again, and that is finished. Circumference is 8 pi. If it said to find it exactly, it'd probably tell us to round it. And then we would go 8 times 3.14, which quick way to check what that would be is you just do 8 times 3, which is 24, plus a little bit more. So the answer, the overall circumference is something a little more than 24, because 8 times 3. But leaving in terms of pi, we're done there. So now let's do our area. Area is pi r squared. Okay, so here's a little mental step you have to take. I know pi, but what's the radius? Well, if the diameter is 8, that leaves the radius to be 4. Okay, because it's half of the diameter. So I can continue with this and go pi times 4 squared. Okay, and if you remember your order of operations from algebra 1, you always do your PEMDAS, your exponents first. So I want to do that 4 squared. That means 4 times 4. Major mistake that people make is they think it's double. They would say, oh, 4 squared is 8. Thinking 4 times 2. No, it means 4 times itself, 4. So that is actually 16, pi 16. And then we're leaving it in terms of pi. So I'm not going to do 16 times 3.14. I can see that would be what? Approximately 48, more than 48. But also notice what I did on the first problem is that we always traditionally want to leave the number in front of the symbol. So I quickly switch this around and go 16 pi. And then I want to get my units on there. It is feet, but it's area, so it's feet squared. So there we go, 16 pi feet squared. Again, pi is a number, not a unit. All right, so we've got our circumference and our area, and then we get to a little bit of a word problem. So we practice doing those, real life, for all you quilters out there. A quilt block includes 12 red triangles. So here's my red triangle with bases of 6 and heights of 6 inches as well. How much fabric would I need to create 12 triangles? Okay, so I need 12 triangles. It would be good to know what the area of one of those triangles is, and then I simply need to have 12 times 12 of those. Guess we're not worried about extra cloth material cutting off and trimming, sort of thing. Okay, so what we basically need to know, okay, what's the area of this triangle? Well, again, I would get in the habit of writing the formula. Area equals 1/2 base times height. So that's 1/2. I see that my base is 6. And I can see that my height, as given by the problem, is also 6. So you can think of that as 36 divided by 2. or you could think of half of 6 and then that times 3. I'm always going to do that because on harder problems I find that easier to cut it in half at the beginning. So I'm going to think of this as 3 times 6 because I went 1/2 times 6 is 3, and then 3 times 6 is just 18. Okay, so 1 square is 18 inches squared. Now again, that's not our final answer because the question is how much fabric would I need to make 12 of these? So I need to then take my 18 inches squared and multiply that by 12. Okay, so 18 times 12 is, you can plug that in. You can do it longhand, or I don't really mind if you use a calculator at home, but maybe you want to get good at not using calculator. The 18 times 12, that's 216. Oops. 216, same units, inches squared. So you need 216 square inches of fabric to quilt your beautiful red triangles for all you quilters out there. I know, sorry, these word problems, sometimes they're just not the most stimulating scenarios. Okay, so there you go, the notes and the questions for homework 1.5. We're going to be working on area, particularly rectangles, triangles, and rectangles, triangles, and circles, both the perimeters and the areas. All right, there will be an exercise video if you want to use that.